Every August and September, the unmistakable pungent aroma of roasting green chili permeates the air across New Mexico and neighboring states. This delectable staple of regional cuisine is green in color, but roasting the chili pepper to deepen the flavor and make the inedible skin easier to remove is hardly environmentally friendly. In New Mexico alone, burning propane to roast the peppers leads to a seasonal emission of approximately 7,800 metric tons of carbon dioxide, the equivalent of driving 1,700 cars for a year. The results of his experiments roasting chili with concentrated sunlight will be shared at the American Society of Mechanical Engineers Conference on Energy and Sustainability next week. The principle behind this research was to see if high-temperature food roasting, not just peppers, could be done with solar and produce comparable results as traditional propane roasting. And the answer is yes, Armijo said. We used green chili to showcase the culture of New Mexico, combining the state-of-the-art facilities and research at Sandia National Labs with the culture, food and people of New Mexico is just so special. What other national lab in the world would have done this? In his day job, Armijo uses the power of the sun at Sandia's National Solar Thermal Test Facility to explore new ways to capture the sun's power for electricity and industrial process heat. Solar roasted green chili. For decades, Sandia has developed technologies that convert renewable resources like wind and sunlight into electricity and useful heat without producing greenhouse gases. Demonstrating these technologies in the real world provides valuable testing and validation. Armijo's demonstration of using solar power to roast green chili could inspire new applications of solar technologies and new avenues of research. With the assistance of several Sandia engineers, technologists and interns, Armijo got a traditional steel drum tumbling chili roaster to the top of the 200-foot tower at Sandia's National Solar Thermal Test Facility and protected the rotor mechanism from the intense solar heat. Armijo's father, a chili farmer and roaster, donated several burlap sacks of green chili and his experience assessing properly roasted chili. Armijo's father grows organic, heirloom chili from seed passed down through multiple generations. Using 38 to 42 of the 212 heliostats, mirror-like devices used to focus sunlight, at the test facility, Armijo was able to achieve a temperature above 900 degrees Fahrenheit uniformly across the roasting drum, he said. This is comparable to the temperature of a traditional propane chili roaster. He used concentrated solar power to roast 3 batches of 22 pounds of green chili, 2 that had been washed immediately prior to roasting, and 1 that was dry roasted. The washed chilies took slightly longer to roast than the dry chili, but the amount of charring was more uniform, and the flavor profile was preferred by green chili connoisseurs, Armijo said. Afterward, Armijo's team returned the chili roaster to the ground, and roasted 3 more batches of green chili using traditional propane. Propane was slightly faster, taking 4 minutes to roast washed chilies, compared to 6 minutes for the fastest solar chili roast. With further experimentation, and using more heliostats, Armijo thinks they can roast chili even faster than with propane, but he didn't want to scorch the chili during his first experiments. With the solar roasting we were actually able to achieve a more uniform distribution of heat, Armijo said. In essence, the heat is reaching all the chili in the front of the roaster. In practice, This has a lot of potential for roasting chili more quickly, with better quality, as well as greener. Green chili. For each of the traditional propane roasts, Armijo recorded the amount of propane used to roast 22 pounds of green chili and found that switching from propane to if the whole state of New Mexico switched to solar chili roasting, the net result would be the equivalent of planting 130,000 tree seedlings and letting them grow for 10 years, annually. It's great to roast green chili sustainably. However, if consumers don't like the taste of solar roasted chili, it will never gain acceptance. That's where the second part of Armijo's study comes in. He found that on average, the respondents favored the solar roasted chilies by 18% for flavor, 12% for smell and 2% for ease of peeling off the inedible skin. That was shocking to me. They preferred the taste because it didn't have as burnt a taste. However, he and his colleagues are exploring a much smaller and more modular solar roasting system that conceivably could be transported to farmers' markets, grocery stores and chili festivals for roasting small batches of green chili, like propane-burning steel drum chili roasters are used currently. In the future, I hope chili roasters will pull up to farmers' markets and festivals with a trailer with a modular mirrored roaster, Armijo said. They just pour the chili in, point the system at the sun, and let it roast. That would just be awesome. But Armijo says solar roasting isn't just for green chili. Concentrated sunlight could also be used to roast other foodstuffs such as soybeans at 840 degrees Fahrenheit for animal feed and human food, grains for beer at 200 to 400 F, almonds and cashews at around 300 and 266 F, and even coffee. French roast coffee is roasted until the beans reach 464 F, and coffee beans are roasted until 350 to 400 F for light roast coffee. Traditionally, fossil fuels like propane or natural gas are used for these processes. Thanks for watching. Please subscribe my channel for more videos.